Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore at DG Khan campus. So dear students, our today's lecture topic is Ethernet frame length, Ethernet evaluation, IEEE 802.3 cable types, fast Ethernet implementation, and full duplex switch Ethernet. So in this lecture we will study these different contents in detail. A frame length minimum 64 bytes, 512 bits, and maximum 1518 bytes, 12144 bits. So this is basically frame length, and frame length is very important because when there is a maximum length, for example 1518 bytes, then the frame will be completed. If there are more than 1518 bytes, then another frame is being developed, or you can say slicing of frame will be according to maximum bytes or 1518 bytes. So frame length is fixed, and after completing a specific length which is maximum of 1518, another frame is being developed. Ethernet evaluation through 4 generation. Ethernet evaluation: standard Ethernet, fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. So whenever we use local area network, data is being transmitted among different devices, we observe the speed of Ethernet, or we observe the speed of data transmission. If there is standard Ethernet, the data transmission speed will be 10 megabits per second. In fast Ethernet, this is 100 megabits per second. In gigabit Ethernet, this is 1 gigabit per second. And in 10 gigabit Ethernet, there is 10 gigabit per second. So nowadays we are going to use high data transmission, and we have to develop best Ethernet using different standards, using different best technologies, using best data transmission, different devices, and we have to use best wired or wireless medias for best data transmission. Categories of traditional Ethernet. Standard Ethernet common implements 10 base 5, 10 base 2, 10 base T, and 10 base F. What is basically 10 base 5? This is normally implemented with the help of bus topology and thick coaxial cable. 10 base 2 is being deployed with the help of bus topology and thin coaxial cable. 10 base T is being deployed with the help of star topology and using UTP, unshielded twisted pair cable. 10 base F is normally deployed by star topology and with the help of fiber cable. What is basically 10? What is base? What is 5? So 10 is data rate. So data rate means data transmission speed, so in megabits per second. So what is base? This is used for baseband. There are two concepts in networks, baseband and broadband, and base is used for baseband. And what is 5? This is basically cable type or length limit. It means after some specific distance, signal quality will being degraded, and we have to use amplifier or repeaters. So this is basically length or length limit. IEEE 802.3 cable types. There are different cables we have discussed recently in our previous lecture, previous slide. 10 base 5, 10 base 2, 10 base 3, and 10 base F. This is basically a name. Next is cable, maximum thick coaxial cable, thin coaxial cable, twisted pair cable, and fiber optic cable. Maximum cable segment length 500 meter, 185 meters, 100 meters, and 2 kilometers. Node segment 100, 30, 1, and topology is bus topology, again bus topology, star topology, and star topology. We have just discussed in our previous slide. If we will use 10 base 5, this is basically standard Ethernet common implementation. Next is thick coaxial cable, next is 500 meters, next 100. This is basically number of devices which may be attached in this network, and bus topology is being commonly used over here. A 10 base 5 implementation. Over here you can see 10 base 5 implementation. 10 base 5, 10 is 10 megabits per second, base is baseband, which is digital transmission, and 5 is 500 meters. So you can see over here transceivers, cable ends, and this is basically simple bus topology, and both ends you can see cable ends, and transceivers cable maximum 50 meters, thick coaxial cable maximum 500 meters. So centralized cable is thick coaxial cable, and a cable which is being attached from device to this coaxial cable is twisted pair cable, and the length of coaxial cable is 500 meter, and the length of twisted pair cable is 50 meters. A 10 base T implementation, this is like same 10 base 5 implementation. Over here 10 is 10 megabits per second, base is baseband, which is digital transmission, and T stands for twisted pair cable. So over here you can see different devices, and we use these devices to connect twisted pair cable, and 10 base T hub is being used to attach all these devices. So this is like implementation of 10 base T over here. A 10 base F implementation, 10 is 10 megabits per second, base is baseband digital transmission, and F is fiber. So 10 base F hub, this is a centralized device which is being used over here, and different devices are attached to this hub with the help of fiber optic cable. So difference between these different implementation is of cable. In previous we have used coaxial cable or twisted pair cable, and over here we are going to use fiber optic cable. Fast Ethernet implementation. Common fast Ethernet implementations are 100 base TX, 100 base FX, and 100 base T4. So 100 base TX is 2 wires, category 5 UTP, so category 5 unshielded twisted pair is being used over here, and in second 2 wires fiber is used over here, and in last 4 wires category 3 unshielded twisted pair is used. So these are different types of wires which are being used over here, as well as you can see the data transmission speed is fast. In the previous slides we have used 10, over here this is 100, so it means 100 megabits per second. Base is again baseband, which is digital transmission, but over here the cable is being changed, fiber optic cable or twisted pair cable, and best categories are being used for best data transmission or to get best data transmission speed. This is our last slide of today's lecture. Full duplex switched Ethernet. You can see different devices over here, and in center we are going to use a switch. All these devices are directly connected to this switch, and this switch is being used to receive data from all these 5 devices and transmit data among these devices. So our device can transmit as well as receive the data from switch. This is called full duplex transmission, in which at the same time data is being transmitted as well as data is being received by the device. So in this way we have completed the concept of Ethernet frame length, Ethernet evaluation, IEEE 802.3 cable types, fast Ethernet implementations, and full duplex switch Ethernet in detail. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.